Welcome, my dear students. So, this is lecture number 2 of chemical reaction and equation. So, let's begin this lecture without any delay. So, here we are. Here, guys, we will study about the law of conservation of mass. Okay, so what is law of conservation of mass? So, this law basically states that mass can neither be created nor be destroyed. Okay, if I give you a basic example to understand this law, so let's suppose that this is a wood. Okay, let's suppose there is a wood, and when the wood burns, then it will create some soot, ashes, and gases. Okay, so the mass of these soot, ashes, and gases, if you combine these mass, then it should equal to the mass of the charcoal and the oxygen. Okay, because when you burn a wood, what you actually burn? You burn charcoal, and we can return it by this C. When this C reacts with oxygen, then it will give us carbon dioxide, okay, some ashes and some gases. So the mass of this charcoal and this oxygen should be equal to the mass of the product. And what is the product? Carbon dioxide, ashes, soots, gases. These are the products. So law of conservation of mass says that mass can neither be created and nor be destroyed. This statement you should remember. That law of conservation of mass states that matter cannot be created or destroyed in a chemical reaction. Okay, so I also gave you the example, and I hope by this example you might be able to understand what I am trying to say. So basically, guys, why we are learning this law of conservation of mass? So its importance you will understand on the upcoming slides. So I will be telling you there. Here you just need to remember that mass cannot be created nor be destroyed. You can say that, okay, according to this law. Now, guys, what happens? Let me give you another example to understand this statement. So, guys, let's suppose that you are burning a candle. So what happens when you burn a candle? Let's suppose this is your candle, okay? And when this is burning, so what will happen? This will convert, or you can say the wax in this candle will convert into the smoke and the gas and soot and the melted wax. Melted wax. So basically, this will also obey the law of conservation of mass. So according to the law of conservation of mass, we know that matter cannot be created or destroyed. So what will happen? The mass of these products, smoke, gas, soot, okay, it should be equal to the melted wax. Okay, because if it follows law of conservation of mass, then the mass of these products should be equal to the melted wax. Okay, I hope, guys, you might have been able to understand what I am trying to say. So now, after understanding this law of conservation of mass, let's move ahead and let's talk about some other important concepts. Okay, guys, so here we are. Here we will try to understand what is a balanced chemical equation and what is unbalanced chemical equation. These are two different things. So we have to understand the difference between these equations. So basically, a balanced chemical equation, you can say, has the same number of atoms of each element equal on both sides. Let's suppose here this is carbon, and this carbon is reacting with oxygen, and as a product it is producing carbon dioxide. So let's talk about this carbon atom. So on the reactant side, or you can say on the LHS side, how many atoms of carbon is there? So you can say there is one atom of carbon. Now let's talk about RHS side. So on RHS side, how many atoms of carbon? There is also one atom of carbon. So it means the number of atoms of carbon on both sides is equal. Now guys, let's talk about oxygen. Okay. So basically on the reactant side, the number of oxygen is 2, and on the RHS, or you can say on the product side, the number of oxygen is also 2. So it means number of oxygen on both sides are same. So all the atoms on the reacted and the product side are same. So this type of equation is known as balance equation. Okay. So what you will say? You will simply say a balanced chemical equation has the number of atoms of each element equal on both sides. So I am writing it here for you that first of all let me erase this, and now let me write this. So basically what is a balanced chemical equation? Which has the number of atoms of each element equal on both sides, equal on both sides. And what sides I'm talking about? I'm talking about this reactant side and the product side. So why do we need to balance a chemical equation? So I told you when we were studying about the law of conservation of mass, that mass can neither be created nor be destroyed. So that's why guys, a chemical reaction should be balanced. Otherwise what will happen? Let's suppose if there is two carbons, if there is two carbons, and here only one carbon is participating in this reaction, so this another carbon will come in the product side, and according to the law of conservation of mass, mass cannot be created. But here you can see a extra carbon is coming in the product, so that's why it is not fulfilling the law of conservation of mass. Or you can say it is not abiding by the law of conservation of mass. So that's why our equation, or you can say an equation, should be balanced. So let me erase this from here, and let's talk about unbalanced chemical equation. So what is an unbalanced chemical equation? So guys, let me write down an equation here so that you can understand this. Fe plus H2O is equals to Fe3O4 plus H2. Now, I do not need to tell you again and again that this Fe and this H2O. H2O is what? It is water. So I do not need to tell you that Fe and H2O is reacting, and they are producing this product Fe3O4 plus H2. Okay, so basically guys, what we have to see here, you can see that, let me write down the number of atoms here. So let's talk about Fe first. So on the LHS side, what is the number of Fe atoms? So this is 1. Okay, on the LHS side, only one atom is present. But on the RHS side, you can see 3 atoms of Fe is there. So you can simply observe here that the number of atoms is different on both sides. Here it is different on LHS side, and on the RHS side it is also different. So now let's talk about this hydrogen. Okay, so on the LHS side, number of hydrogens are 2, and on the RHS side it is also 2. Now let's talk about oxygen. So on the LHS side, the number of oxygen is 1, but on the RHS side it is 4. So what we can observe here, we can notice that the atoms on the reactant side is not equal to the atoms on the product side. So that's why this equation is unbalanced chemical equation. Why? Because the number of atoms of each element in reactants is not equal to the number of atoms of each element present in the product. So that's why this equation will be called unbalanced chemical equation. I hope guys this thing is clear to you. So now what do we have to do? If this equation is unbalanced, then we have to balance it. Why do we need to balance it? Because according to the law of conservation of mass, that number of atoms, or you can say number of atoms on both sides of each element should be equal. Otherwise, it will not abide by the law of conservation of mass. So that's why we need to balance this unbalanced chemical equation. If it is already balanced, then it is okay. But if it is not already balanced, then we do have to balance it. And how do we balance a chemical equation? That is our upcoming topic. Okay, so here in this equation, we can simply balance it. And how can we do that? Is if I make some changes. How can I make some changes? Let me tell you how can I do that. So this is your equation. Now if I multiply this Fe by 3, okay, and if I add 4 here, and if I again add a 4 here, then this equation will be balanced. Now I know that this thing you are not able to understand now, that what did I do? I added 3 here, then I added 4, and then again I added 4. So you might be confused that how can I do this? So guys, you do not need to be confused here, because on the next slide I will tell you that how do we balance a chemical equation. Here I am just showing you that this was an unbalanced chemical equation, and after applying some changes, or after making some changes, now this equation became balanced chemical equation. Okay, so to check whether it is balanced or not, let me again make a table. Fe, H and O, LHS side, and then RHS side. Okay, so you can see then the Fe on the reactant side is 3 and Fe on the product side is also 3. Okay, Fe means iron. And hydrogen on the LHS side is 8. Now you might be wondering, sir, how can it be 8? So I will tell you later how can it be 8. But for now, you can just understand that this is hydrogen. Hydrogen is H2. So there are two atoms of hydrogen. So when these two atoms will multiply this 4, then it will become 8 atoms. So that's why I wrote 8 here. Now let's talk about how many atoms are there on RHS side. So on the RHS side, the atom of hydrogen is also 8. Now guys, let's talk about oxygen. So how many oxygen atom on LHS side? So oxygen atom on LHS side is 4 and on RHS side it is again 4, like this. So now you can see that on each side or on the reactant on the and the product side, each element has equal number. You can see Fe is 3 on LHS side and on RHS side it is also 3. Hydrogen here is 8 on LHS and on RHS it is also 8. On LHS oxygen is 4 and RHS is also 4. So that's why this equation is an example of a balanced chemical equation. I hope guys this thing is clear to you. Now let's talk about the next topic. So let's move on to the next slide. Okay guys, so here we are. Here we will study balancing a chemical equation. Okay, so when I balance the previous equation which we saw on the previous slide, then you guys might have been confused that how did I do it. So after some time, after explaining on this slide, you will be master on balancing a chemical equation if you study with all your concentration. So let's talk about this simple equation. Let's talk about this simple equation. So first of all, we know that how do we write a chemical equation. So hydrogen is what? H2. It is a symbolic representation of hydrogen, and I will add a plus sign between reactants. This is oxygen. Oxygen is O2. Okay, and I will have to add an arrow to show the direction of the reaction, and the chemical formula for water is H2O. Okay, so this is now become a chemical equation. Now first of all we will check whether this chemical equation is balanced or not. So to check this, what do I have to do? First of all, I will need to write oxygen, then hydrogen, then I will write LHS, then I will write RHS, and I hope you know RHS is for product side and LHS is for reactant side. So how many atoms are there on LHS of oxygen? 2. But how many atoms are there on RHS of oxygen? That is 1. How many atoms of hydrogen? 2. How many atoms of hydrogen on RHS? That is 2. So it means hydrogen is balanced, but oxygen here is not balanced. So what do I have to do? I have to balance this oxygen. Then only I will be able to balance this equation. So to do that, let me give you how can we do it. Guys, To balance this equation, first of all, let me write this equation here. H2 plus O2 is equals to H2O. Okay, so I know that hydrogen is balanced because number of hydrogen on both sides equal is equal. Okay, but oxygen is not balanced. So what do we do? Basically, we multiply with a number so that it can be balanced. Okay, so what do we do? We simply multiply the element with a number so that it can be balanced. So here oxygen is 2, but here it is only 1. So I will multiply, let me write it with other pen. If I multiply here with 2, then you can see, now if I write or if I make the same table again, then you can observe that here hydrogen is 2. Sorry, hydrogen he is will be written here. It is 2. Here it is 4. Here it is 4. Oxygen here is 2. On the reactant side it is 2. And on the product side it is also 2. So it means oxygen now is balanced but hydrogen is not balanced. Okay, because you can see the number of hydrogen becomes 4 because hydrogen, if you write hydrogen, it means it has 2 hydrogen atoms. So when these 2 hydrogen atoms will multiply with 2, then it will become 2 by 2 is 2 into 2 is equals to 4. So it will become 4 hydrogen atoms. Okay. So guys, to balance this hydrogen, what can we do? We can simply multiply this 2 by 2. So if I write here 2, then you will say that now the number of hydrogen will become 4. Okay. So now if you see this chemical equation, then this is become a balanced chemical equation. How? Because number of hydrogen is 4 here and number of hydrogen on the product side is also 4. Okay. If you talk about oxygen, the number of oxygen on the reactant side is 2 and number of oxygen on the RHS side it is also 2. So that's why this equation now has become balanced chemical equation. So I hope guys this thing is clear to you and you might be able to understand how do we balance a chemical equation. Okay, so if still you are not sure whether you are able to solve this equation or whether if you are given an equation which is unbalanced, then will you be able to balance it or not, then you will not to be worry because on the upcoming slides we will be solving some questions on this balancing a chemical equation where you will be master on balancing a chemical equation. Okay, so let's move ahead and let's talk about the examples which are coming on the upcoming slides. Okay guys, so here we are. Here some examples are given and now we will try to solve or we will try to balance these chemical equations. Okay, so these equations first of all we will check whether they are balanced or not. If they are balanced then it is okay. If they are not balanced then we will balance them. Okay guys, first of all let's try to solve this first question. So this is Fe plus H2O is equals to Fe3O4 plus H2. Okay. Now, first of all, we will check whether this equation is balanced or not. And you already know how do we do it. We will simply make a table where we will write all the elements Fe, H, which is hydrogen, and oxygen. Okay, so this is what hydrogen. I know that most of the students know this. This is hydrogen, this is oxygen, and this is iron. Okay, so tell me how many iron is present on the reactant side, or you can say on the LHS side. So one iron atom is present on the LHS side, and if I talk about on RHS side, then you will say that 3 iron atom is present on the RHS side. Now guys, tell me how many hydrogen atom is present on the LHS side. So 2 hydrogen atom is present on the LHS side. And how many hydrogen atom present on RHS? That is 2. So it means hydrogen is balanced. Now tell me guys that how many oxygen is there on LHS? So only one oxygen is on the LHS side. And how many oxygen on RHS? So 4 oxygen is on RHS side. So guys, what do? We start balancing with the element which is highest in number. You will have to keep this in your mind that whenever you find a difficult equation, or in the beginning you can apply this method on every equation. Okay, because after some time what happen, if you keep solving this type of question, then you will become such master of balancing the chemical equation, then you can directly do it without making this table. But in the beginning I suggest you to make the table first and then try to solve the question. Okay guys, so we will start balancing the atom which is highest in number. So you can see guys, we can multiply this oxygen with a number 4. Okay, so if you multiply 1 by 4, then it will give you again 4. So now you can see the oxygen is balanced. Okay, so you have to multiply this 4 here like this. You have to write this 4 before the substance. Okay, so now you can see the number of oxygen is 4 on the reactant side, and on the RHS it is also 4. So it means oxygen is balanced. But when you multiply this by 4, then oxygen becomes 4, but this hydrogen will also become 8, because this number is will also be multiplied by the hydrogen atom. So because I told you in the previous slides as well, then the hydrogen atom has 2 hydrogen. Okay, has 2 hydrogen. So when these 2 hydrogen will multiply with 4, then it will give you 8. Okay, so now the hydrogen becomes unbalanced. Previously it was balanced, but now it is become unbalanced. So what do we have to do? We have to balance this hydrogen. So to balance this hydrogen, what can we do? We can multiply on the RHS side by 4. So it will become 8. Okay. Now guys, you can see that the LHS and the RHS of hydrogen is same. Here also it is 8 and here also it is 8. So it means the hydrogen atom has become balanced. I hope guys this thing is clear to you that the hydrogen has become balanced. So I have to add 4 here. Okay, I have to add a 4 here. Let me make it clear for you. So this is your plus sign and this is 4. Okay, now guys, you can see that hydrogen and oxygen is balanced, but iron is not balanced, because iron, the number of atom of iron on LHS is 1, but on RHS it is 3. So what can we do? We can simply multiply here with 3. So it will become 3, and you can see now iron is also balanced. So I will write 3 here. Okay. So now you can see that this is a complete balance equation, because the number of atoms on the both side, on the reactant side as well as the product side, is same. Okay, so that's why it is a balanced chemical equation. You can also check Fe is 3 on reactant side and Fe is also 3 on product side. So this is balanced. Hydrogen is 8 on the reactant side, and on the product side it is again 8. Oxygen is 4 on the reactant side, and on the product side it is also 4. So this is why it is a balanced chemical equation. Now guys, let's talk about the second example. So second example, we will do it a little bit faster, because we are solving, we have already solved two questions on this. So this should be a little bit easier for us. So basically, let me write down this equation: Fe2O3 plus Al, Fe plus Al2O3. Okay. So what will I have to do? I will simply make a table. So let me erase this previous table from here. So let me erase this previous table. I hope guys you are able to understand what we are doing here. Okay. So basically, first of all, I will write Fe. Okay. And then this is what? This is aluminium. This Al is a symbol for aluminium. Aluminium. Okay. And you are familiar with this oxygen, and you are familiar with Fe. So I don't need to write it here. So this is Fe, this is oxygen, and this is aluminium. Now guys, you have to write LHS and RHS. This is, let's suppose, LHS and this is RHS. Now on the LHS side, how many atoms of Fe is present? So that is 2. On the RHS side, how many atoms of Fe is present? So your answer is 1. Now on LHS side, how many atoms of oxygen is present? 3. And on RHS side, it is again 3. Now, what about the aluminium? So aluminium here on the LHS side is 1, and on the RHS side it is 2. Okay guys, I hope this thing is clear to you. Now, to balance this, what we can do, first of all, we will start balancing with this iron. Okay. So to balance this, I will simply multiply it with 2. Okay. And if I multiply it with 2, then it will become 2. So let me write 2 here. Now you can see iron is balanced, because on reactant side it is 2, on product side it is also 2. Now guys, you can see that aluminium on the product side it is 2, but on the reactant side it is only 1. So what will I do? I will simply multiply it with 2, and it will also become 2. So I will write 2 here. Okay. Now guys, you can see the reactant side and the product side is same. I mean to say that the number of atoms of each element on both the side is same. So that's why now it has become a balanced chemical equation. Okay. Previously it was unbalanced, but now guys it is a balanced chemical equation. I hope you might have been able to understand these examples. Okay. Now guys, we will solve this last example so that we will be master on this balancing of a chemical equation. Okay guys, so let's start and solve this. So guys, now you tell me that what we do. We will make a table again, carbon, oxygen. Okay, so I will write hydrogen. Now this is LHS side and this is RHS side. Okay, so how many atoms present on LHS side of carbon? So that is 3. And how many atoms are there on RHS side? That is 1. So how many atoms of oxygen on LHS side? That is 2. And how many atoms of oxygen on the RHS side? That is 3. And what about the hydrogen? 8 on the LHS and 2 on the RHS. So guys, what I will do to balance this, first of all, I will start with hydrogen. So I will multiply this hydrogen with 4. Okay, so this will give me 8. So hydrogen will become balanced. So let me write this HC3H8 plus O2 equals to CO2 plus H2O. Okay, so let me change the pen and let me multiply this hydrogen with 4. Okay, but now you have to see that if I multiply hydrogen with this 4, then this oxygen will also become 4. So this 4 oxygen, when this will add in this 2 oxygen, then this will become 6 oxygen. So now oxygen is not 3 on the RHS side. It has become 6. So I will write 6 here. Okay. So now guys, what will happen if I want to balance this equation? So I will balance this carbon. Okay. So what will I do? I will simply multiply this RHS side of the carbon with 3. So it is become 3. Okay. So let me write 3 here. Now you can see the carbon is balanced. It is 3 here and it is also 3 here. But guys, because I multiply this carbon with CO2 with 3, then oxygen also became 6. And this 6 will add with this 4 and this will become 10. So now, if I talk about the number of oxygen on the RHS side, then it has become 10. Okay. So guys, now what do I have to do? I have to balance this oxygen because carbon is balanced, hydrogen is balanced, but this oxygen is not balanced. So to balance this oxygen, I will multiply on the LHS side by 5. So it will become 10. So I will have to write 5 here and it has become 10. So you can see that all the atoms of this equation is balanced now. So this is a balanced chemical equation. So I hope guys all these things are clear to you. Whatever we have learned in this lecture, okay, all the concepts and all the numericals. Okay guys, let's move ahead and let's go to the next slide. So guys, here I am ending this lecture. Thank you so much. I hope you enjoyed this lecture and we will meet in the next lecture. Bye bye.